20,000, I will pay you back. Minister will at least send me. And I'm working on one experiment very soon, maybe next in some conference. One of my students will present this paper. We are working on it. We already done, because the problem is free tools are good in English, but in Urdu and Sindhi language, we need to work on it. So my image, my video is already done, but the sound is, we are working on it. So it looks like me is requesting and having in trouble. And so social experiment I'm going to do very soon, not with the Lahore friends, with the Karachi friends, so that I'm disturbing here, so you know there's a fact. So I will see how the response is coming from the community, what awareness they have. So this is again a big problem that, you know, people having the same face, same voice, and they are requesting for some money, and video calls are coming in such a way. Next, please. Okay, so again, deceptive AI claims. The Federal Trade Commission has filed complaint against several AI-powered business schemes using, you know, fraud. So, lot of website, also State Bank of Pakistan said, don't use them; they are fake. This is not the phenomena which is national. This is an international phenomena where internationally people are also having same trouble. And the national level also, because here already, if you look at the official data, 62% people are, you know, literate. Now, 62% means those who read and write their name only. So, in this fact, you know, calls are coming, and people are. I'm receiving so many calls from mobile number saying I am a major, and I have you, and they have my ID card, they know my address, and they know my name. Three things they know. Rest they are hitting. So one day I received a call that Dr. Tariq, your nephew is in police station. I said, okay, I don't have a nephew. I said, okay, I understand. I said, okay, what is his name? Then there was a fake nephew, Mamu, help me. But I know because I'm a Sindhi speaking, so he cannot speak with me in Urdu. So one point. The second, I told him that, okay, I'm not going to do anything. Do whatever you want to do, you know, go for FIR. Then he said, oh, I know you are selling the fake medicine. I said, I'm not the tech doctor, American doctor, so thank you. So they are hitting just to get some money. So many, you know, organizations here, they are, next please. I can understand time is, so countermeasures are very important. Now we need to discuss countermeasures. Yes, please, next. So there are efforts we need to do. Okay, so first thing is awareness and, you know, planning. I mean, if I'm receiving a call from 99, you know, the prefix may be 042 for Lahore, 021 for Karachi, 051 for Islamabad, so I can understand this is a government official. Again, it is possible that there are tools, you can, you know, use that tool and that number can come on the screen. But normal, you know, the scammers, they are not using, so they are using mobile phone. Now, mobile phone by a police officer, by an army officer, by a bank officer, don't respect. Say, thank you very much. I am going to cut the phone. I am going to report you. Now, how many are we reporting to PTA those numbers? This is again problem, because problem exists, we are not doing anything. So awareness is very important. I mean, I can understand even university students who are not involved in cyber security issues, maybe some of my relative medical students and some other, they were got in trouble, but alhamdulillah, you know, initially they were saved. So first thing is the awareness effort. So we need to create awareness, training, and you know, I'm preparing one complete awareness session that how to recognize deep fake and other things. So this one of my paper is on deep fake also. Regularity and policy efforts. Okay, this is as I said, this is not a national problem. This is an international problem. But again, internationally, you know, code of conduct is there. So many instructions, so many things are there. But again, we need to know that what efforts we can do. Few days before, one of my cousin working in a cyber security agency, the inspector, he was giving a training to the additional session judge. And surprisingly, additional session judge, who are the one going to make a decision, they were not aware of any of these things. This is sometimes very difficult. On the other hand, I'm giving training to the officers, grade 17, grade 18, and grade 19 syndrome and officers. I'm including in my presentation the cyber security threat and others, so that they at least knew something before they got in trouble. So regulatory efforts are very important. Policies are PICA rule 2016, maybe very good rule. I cannot say, I'm not a lawyer, but how to implement it, how to, even, it's very difficult to find out the jurisdiction that where police come, where FI come. So very difficult. So this is, we need, some efforts on regularity and policy. Next, please. Collaborative efforts. So we need a global framework. UNESCO is working on it. We need to join United Nations, UNESCO, and other international organizations. European Union is working on it. So we need to join together and see the best practices and adopt those best practices. Organizational efforts. Organizational efforts mean every organization now, as our university, we are having now good firewall, and even though our data is on the cloud, but again, we want to move our data from cloud to our own premises. So we are thinking about setting up a data center, but so we need more, security, good firewall, what is going outside, what is coming inside are supposed to be monitored, and what to do, what not to do, a code of conduct from the institute, organization supposed to be there, keeping in view all these things. Next, please. Next. Okay, now coming to technical effort. This is very, two slides are important, tool-wise. So data integrity checks are important. I'm receiving, yes, 10 minutes now, I've finished 5 minutes, don't worry. Bias auditing is going on. Advanced testing is very important. Robust algorithm required. Secure APIs. Digital watermarking can help some organization. Blockchain is a very important technology, and some tools are there. So next, please. 2 more slides, I think so. Next, please. Yes, so tools, I'll go through tools. These tools, I already, put some efforts, but I don't have time to now, so I'm doing some exercise and giving to my student to, explore more. So Microsoft Video Authenticator is a very good tool which is helping to detect, analyze whether these videos are deep fake or not. Deep Rear Scanner is one of the good software, and Sensity AI
can reduce the odds of AAC by 24%, or maybe in non-tea drinking women, those in the highest quartiles of flavonoid intake had 89% lower odds of severe AAC. So the take-home messages from this part is that AAC can be easily identified, is common, and captures new non-traditional cardiovascular disease risk information. It's a marker of the presence of asymptotic CVD, and it identifies people with higher CVD risk and poorer long-term prognosis. And finally, AAC is independent of CAC. We'll now discuss our contribution in this field. So uh, I have a group over here of about 8 PhD students and 2 postdocs. We're working with Professor David Suter and also with our clinical experts. Um, and the purpose is to detect this calcification using machine learning. So as I discussed earlier, that this is the calcification in the DEXA scan, and this is how a DEXA scan looks like. This special scan, this scan is from the GE machines. Now, in this particular slide that you're seeing, there is a lot of calcification, and it's shown by the arrows. In this particular image, there is some calcification, and you can see that from the arrows. And in this one, there's no calcification. So the interesting thing is the aorta is not visible in a DEXA scan if there's no calcification. So what do we do in a conventional machine learning? In conventional machine learning, you have features that you pass on to an LDA or an SVM, any supervised machine learning algorithm, and then you can then get some outcome, right? But when you use deep learning, what you can do is just pass on an image, and it can tell you, after training, of course, it can tell you a lot of things about the person. But going back to the basis, how does the aortic calcification compare to object detection? So as you know, ImageNet was the basis of the huge data set that was used to train machine learning algorithms, the deep learning ones, AlexNet and all. And these were the sort of objects in that. So this is a particular object. This is of a dog, an image of a dog used to train the deep learning networks. And you can see that our image of our DEXA scan or the calcification is comparable over here. So just to show you, as compared to a normal input image of a, say, AlexNet or from ImageNet, uh, the size of calcification is given. And we're not using RGB, we are using grayscale. So again, you can see the difference. And finally, this is what happens when we have low dose DEXA scans, which are really noisy. Now, we started this research when Professor Lewis, Professor Sutra, and myself, we started collaborating about 6 years ago. And we first of all took the data set and noticed that there were a lot of um, challenges in it. So the first thing was that there are defects in the vertebral edges. As you can see, the vertebral edges are not very refined. So it's difficult for you to localize the aorta. The second was they're very low resolution, and there is so much of noise in it. And then there are gas bubbles just around the aorta, which confuse the unsupervised algorithms. The other issue is of limited annotated data sets. It takes roughly about 15 minutes for a trained radiologist to read a scan and score it. And also, the data sets that we have most of the scans have a score of 0 or 1, and very few have a score of 24. Uh, so we have interclass similarities. So even when you have we have three different classes in calcify in detecting this calcification. You could have scans from three different classes, but you'll see that there's very little difference within the images. But sometimes when you have scans that have the same score, yet they look very different. So there's intra-class variation. So with these challenges, we started working on a machine learning algorithm. And one of the things that we wanted to do was to have intervertebral guides between these between the vertebra, because that helps the radiologist to score these calcification easily. The other thing that we're doing is to localize the lumbar vertebra and then to predict a cumulative 20 AC24 score. So an image is given as an input, and a predictive cumulative score it can be calculated the output. The third one is getting granular AAC level scores. So input a DEXA scan and it will give you the granular scores across each vertebra, and then you can add them to get an AC24 score. And we have tried to make this more explainable, and so this is another work that we're doing, and now I'm going to discuss these four. So the data sets that we have, incidentally, we have the largest collection of annotated data sets in the world for this purpose. We are the only group, we are the world leading group that is working on detecting aortic calcification using machine learning. So the first one is GuideNet, which was published in Dicta about 3 years ago. And the idea was to have a scan, pass it through a ResNet, and then detect the centers of the vertebra, and from there calculate a way to go and see the to detect the four corners of each vertebra, and then mark lines between these two, which are called intervertebral guides. This work has been extended now and is now under review in the transactions on medical imaging, where my student has gone to the thoracic region as well. So from T1 to T12 and L1 to L5, he can easily detect the four corners. Um, the second work that I want to discuss here is the version 1 of our algorithm, which was published in eBiomedicine last year. Yes. So we have the scan, we pre-process it, which includes cropping and all, and then this pre-processed scan is passed to a CNN encoder to extract features, and then a regression head outputs the AAC score. So we have about 5,012 lateral spine images from Hologic and GE machines. We have 4 different models of each machine. So there are only two major manufacturers of DEXA scans in the world. And you can see the results over here. Uh, the correlation of our predicted scores with the human scores is around 81% for the Hologic 4500A and 84% for the Horizon scans. And this is so the data set that we used is called is the Perth longitudinal study of aging women. This is the data set of women. This is the data set that was collected from women in about 1912 and who were born in 1912 and between 1912 and 1920. So most of them are not alive right now, and that way we know how they died. So correlating the score, the machine learning scores with the cause of death, we have we see that low AC score with low AC score, the chance of all cause mortality is 4%. With a higher AC score, it was 10%. And this is the result for GE Lunar and GE DEXA scans. GE DEXA has a very good output of 91% correlation. The real world clinical validation of this work was done using about 8,000 scans from a community based cohort in Canada. And we did not have any ground truth for this cohort. So we predicted the scores for these 8,500 scans. And then we found the relationship between all-cause mortality and MACE and secondary endpoints. And the results were really good. The version 1.1 of this work, which uses a contrastive learning ordinal loss um, for calculating the ASA score, was published in MICAI last year. And it uses two datasets, the hologic dataset and the IDEXA scan. And the results, as you can see on the slide, were pretty good. The average accuracy was around 85%, and the Pearson's correlation was 89% for the KIFOS. And for Manitoba DEXA scans, it was about 91.2%. And again, the correlation with the cause of death was very high for each class. We now come to the granular score. So it's not just that you can predict the 24-point score, you can also predict the scores across each vertebrae. And so we had a lot of challenges, which I'm not going to go through in detail, but we passed these scans through encoder to extract the features, passed those features through an LSTM, and iterated 4 times to get posterior and anterior scores. And eventually, uh, this is how the machine would output the score. So given L1, L2, L3, L4, we would have ground truth and we would have the predicted scores. And you can see two cases where this was a success and a failure case. The results again were good, about 82.5%. This was improved in another work which was published this year in MICAI 2024 using contrastive learning. And this gives a bit more explainability to how the scores have been predicted. And you can see the GradCam visualization over here, which shows that across each vertebrae, these were the scores, and this was how it was calculated. And there are some more results over here. A comparison was done with our version 1 initial version, and you can see the results are about 5% higher than the previous work. Now, the interesting thing is that we're not stopped only at measuring these scores or calculating these scores, but we also want to see what's the impact or what's the eventual use of doing this. So one of the interesting things is that if you do this manually, it takes a long time. But if we can use machine learning scores, then we can calculate these scores in thousands and thousands of patients. So this is a work that we were recently, about last year, we were funded for this for about $1.2 million. And we can now predict scores in UK Biobank, which has about 55,000 scans, and in the Canadian longitudinal study of aging, which has around 30,000 patients. So we have predicted scores in those cohorts, and we can use that to not only detect, produce the scores, but also see, look at the genetic models. And so this is I'm leading the machine learning part of this grant, and we have predicted the scores, and then we pass these scores on to the clinicians who do their. All right. So this is the results. These are some of the results from that study. And how do we use this information? So this information can be used and it can be provided to the patient. So this is one of the major studies that we're doing now, where we are providing these scores and the scans to the patients, and we are now looking at how they are changing their dietary behavior. So this will eventually tell us and let us know how people have changed their dietary behavior and improved their chances of living. So that's, I guess, this is that grant, and these are the people, roughly 300 baseline patients, and 500, 150 will go through the randomization trial, and 150 are given their scores. So with that, I thank you all, and I acknowledge all my collaborators here who have been working with me on this project. Thank you so much.
Thank you, Dr. Zulkarnain Gilani, for your interesting talk. Is there any questions, please? Is there any questions, please?
So I'm just wondering, usually in the medical way they have their own model, like a case model. So they use it for predicting the solution of the X-ray. So did you go with that what your work?
I'm sorry, I really could not hear that question from there.
So can you hear me?
Can you use a different mic? So the mic that I think the MC was using has a better volume.
So, Doctor, can you hear me now?
Yes, thank you so much.
Oh, okay. So I was just actually thanking you for the wonderful talk that you gave, and
Thank you.
we learned a lot. So I was wondering, so in medical domain, they also have their own models like Grace risk score for predicting, let's say, next cardiac attack. So did you also look into that and compare your results with their results, because they have also like an alternate model for that?
Yes, there are definitely some models that are especially working for X-rays. And there was recently a paper that was published in MICI 2024 where the input was an X-ray and they could predict about the cardiovascular diseases. So some of the characteristics of the cardiovascular disease just from the X-ray. But see, our in data is very different. It's not X-ray. These are DEXA scans. They're very low quality, and the off-the-shelf existing networks don't provide good results for these data sets.
Thank you, Dr. Gilani, for your highly engaging session and for sharing your expertise with all of us. Thank you so much.
You're most welcome. Thank you for having me.
Thank you, Dr. Gilani, for your very good talk. As the first half concludes, I request Dr. Wakar to kindly come to the stage and present shield to Dr. Lee for his contribution to our conference. Dr. Gilani, we have reserved your mentor and will ensure that it reaches you in due time.
Thank you so much. Thank you.
Thank you, sir. Thank you, everyone. We now invite our guests to proceed for lunch. and our session manager will guide you through the area. Kindly note the session will resume at 2 p.m. and enjoy it.